Hi, I'm Udi from Commodore, and in this video I will show you how Commodore enables data teams to gain visibility and operational understanding of the data pipelines they are running on Kubernetes, as well as troubleshooting them independently when something inevitably breaks. Commodore's capabilities for workflow automation engines like Kubeflow, Airflow, Apache Spark are designed to tackle three main challenges. Firstly, lack of visibility into workflow failure. So when a job fails, users often have no idea why, and the logs are scattered across multiple pods. And if a pod is deleted, then all of its historical data is gone, making troubleshooting nearly impossible. Runaway costs. As you know, ML workflows consume massive compute resources, and without proper monitoring, costs can spiral out of control before you even notice it. And lastly, the dependency on platform teams. The barrier of entry for data engineers is far greater than that for application developers. So when issues arise, they're often escalated to the DevOps, MLOps, or platform teams, which causes ticket overload, slower resolution times, and bottlenecks that are affecting the development and the overall business goals. So let's see what life looks like for data engineers with Commodore. So if I go to my overview screen and scroll down to the Kubernetes add-ons tile, I could see that I have two issues with my workflow automation tools. Clicking on it will take me to the Workflows tab, where I can see all of the workflow engines that I am currently using, and some relevant metadata, and the most important thing, the status. So right away, we can see the two issues that were highlighted in the overview screen. First one is an issue with Airflow. So if I click on it, I can see a timeline of all the workflows running concurrently here. And I can see that indeed the workflow failed at some point. And it's also important to note that Commodore differentiates between different phases of the workflow. So just because it's pending or not ready doesn't mean that there's anything wrong with it. But when there is something wrong with it, Commodore will let you know. So you can count on Commodore to not just flag every pending pod, but only the ones that require your attention. So if I click on this failed pod, I can see that this pod has failed because its hosting node was terminated. So this is quite a common event, and we can see here, thanks to Claudia's AI analysis, we can see exactly what happened, when it happened, and why. So this is a quite common use case where the node was terminated due to a scale-down event by Carpenter. So we already see how different add-ons can affect each other, and we will have a separate video about cluster autoscalers. But for now, we can imagine as a data engineer, a scale-down event caused by Carpenter is something completely out of my scope and out of my understanding. But with Commodore, it's easy for anyone to understand the sequence of events, what they mean, and what I should do in order to fix it. So without reading any Carpenter documentation or going to AWS support or escalating to my MLOps team, I can just simply with one click rerun this workflow. And I can even have a proactive approach to it and add an annotation to the pod to avoid a similar event recurring in the future. So sending my MLOps engineer a screenshot of this will definitely get me some points with the platform team. So let's take a look at the other failed workflow, which is in Argo Workflows. And same here, this is not DUG, so we have a different timeline here, but same as before, we can see when pods are pending and when they are running, and most importantly, when they fail. So here again, we can see that this pod failed due to a scale-down event. Once again, Carpenter is being a bit naughty, but Claudia is here to help us and provide with clear step-by-step instructions to not only remediate the specific failure, but also prevent it from ever happening again. So, for example, increasing the node pool CRD limit for Carpenter is a good step, but something even more advanced is adding taint to the GPU-based nodes, so that non-GPU workloads won't be scheduled to those. And the critical GPU nodes will always be free to accept workloads that really do require the GPU power. All of those are things that you can do and perform within the Commodore platform without having to switch to other tools and without having to escalate to anyone else. So this capability gives data engineers full ownership of their workflows. If something breaks, they know how to fix it themselves, and they know about it in time. So as soon as something is suspicious or risky, Commodore will let you know and will guide you on how to solve it yourself.